A chimpanzee mother in the Kibale forest carries her dead infant against her chest for 6 days straight. She screams. Not once, not twice. She screams for hours at a stretch, a full-throated distress call that carries across the canopy, and other chimps hear it and stay away. Primatologists who study grief in great apes have documented this exact behavior repeatedly, carrying the body long after decomposition begins, refusing contact from other females, vocalizing in a way that unmistakably reads as anguish. Every physical marker of devastation is present. Every marker except one. Her eyes stay dry. Now picture a human mother in the same situation. She doesn't scream, or she screams and something else happens too. Her eyes fill, her face crumples in a specific pattern no other animal's face makes, and clear fluid runs down her cheeks in silence. Same loss. Same species-level grief response underneath it. One visible difference separates them, and it's not intelligence, and it's not the depth of the feeling. It's tears. So here's the actual question worth sitting with. Every mammal with a nervous system complex enough to bond with offspring can grieve. Elephants stand over their dead. Dogs whimper and refuse food. Chimps scream for days. But nothing else on the planet, as far as researchers have been able to document, weeps. If subscribing sounds good so far, go ahead and hit it, and drop where you're watching from in the comments. The obvious assumption is that crying is just what distress looks like when it gets intense enough. Loud enough grief becomes tears, the same way loud enough laughter becomes tears of a different kind. That assumption falls apart the moment you look at what's actually happening inside a human eye, because there isn't one system producing tears. There are three, and only one of them has anything to do with feelings at all. The first is basal tears, the thin, constant film that keeps your eyes from drying out while you read this sentence. The second is reflex tears, the flood that happens when onion vapor or wind or a stray eyelash irritates the cornea. Both of these exist across the animal kingdom in some form, because both are purely mechanical. A rabbit produces reflex tears, a cow produces basal tears. Neither is crying in any sense a human would recognize. The third category is the one that matters here. Researchers call them psychic tears, or emotional tears, and they're triggered not by anything touching the eye, but by something happening in the brain. Grief, joy, frustration, being moved by a piece of music. As far as the evidence shows, this third system exists in exactly one species, us. In the 1980s, a biochemist named William Frey ran an experiment that sounds almost too simple to matter. He had volunteers cry while watching sad films, then collected their tears in small vials. Separately, he collected reflex tears from the same people by having them chop onions. Same eyes, same tear ducts, same salty fluid by every visual measure. Under analysis, they weren't the same fluid at all. The emotional tears carried a noticeably higher concentration of protein, along with hormones tied directly to stress response, ACTH, prolactin, and a natural painkiller called leucine and enkephalin. Whatever crying is, it isn't just eyes leaking. The body is manufacturing something specific, on purpose, and only when the trigger is psychological rather than physical. Here's where the timeline gets stranger. Human infants cry from the first minute of life, loud and constant, exactly the way every other primate infant does. That part isn't unique to us. What's unique is that a newborn's cries are almost always dry. The tear ducts responsible for emotional weeping aren't fully online yet. Most babies don't produce visible tears with their crying until somewhere around 3 to 6 weeks of age, sometimes later. The vocal system and the tear system aren't the same system switching on together. They're two separate pieces of hardware installed on two separate schedules, which is a strange thing to build if crying were just one continuous reflex. If this is the kind of thing you find yourself thinking about later tonight, subscribe and turn on notifications. It helps us keep making this. That separation matters because it points toward tears doing a job the scream can't do on its own. And the leading explanation for what that job actually is starts from something that sounds, at first, like a flaw. Tears blur your vision. Cry hard enough and you genuinely cannot see well. Faces smear, edges disappear, the room goes soft at the margins. For an animal whose ancestors spent millions of years needing sharp vision to track threats and read faces, that's a strange cost to build into a signal on purpose. Unless the cost is the point. Researchers working from the handicap principle in evolutionary biology, the idea that some signals are only trustworthy because they're expensive to fake, have proposed exactly that. A scream can be performed. A grimace can be performed. Deliberately blurring your own vision in front of another person, in a species where physical vulnerability used to mean real danger, is a much harder thing to fake convincingly. It works as proof precisely because it costs something, which explains why it's silent and why it's visual rather than vocal. A scream broadcasts across a valley. Tears only work at close range, on someone who's already looking at your face, which means crying isn't a warning sent outward, it's a message sent inward, to whoever is standing close enough to already care. The blur explains why tears work at close range. It doesn't explain why humans are the only species that develop this at all, and that answer seems to trace back to something most people never think about: the mechanics of the human face itself. Tear ducts drain into the nasal cavity through a small channel called the nasolacrimal duct. In most mammals, that duct sits low and wide, angled to drain efficiently, which is part of why a crying dog's eyes just look wet rather than streaming. The human version of that duct is narrower and positioned differently, a side effect of how flat our faces became compared to snouted ancestors. Flatten the face enough, and the drainage system that used to whisk tears away quietly starts backing up instead, spilling over the lower lid and running down the cheek in a visible line. Researchers who study craniofacial evolution have pointed to this as one plausible piece of the puzzle. Not the whole explanation, since plenty of flat-faced animals still don't weep, but a genuine anatomical precondition that had to exist before visible crying could ever become a signal worth evolving further. A precondition isn't a reason, though. Plenty of things could exist as harmless byproducts and never get selected for. Something had to make an overflowing tear duct worth keeping and refining across generations, and the leading candidate for that something is the same thing that shows up in nearly every conversation about early human survival: the size of the group. Chimpanzee communities typically run somewhere in the dozens. Early human bands, once cooperative hunting and shared childcare, became central to how the species lived, likely operated at a noticeably larger scale. Enough individuals that constant one-on-one signaling stopped being practical. A scream still works in a group that size, but a scream is loud, and loud has a cost. It draws predators, it draws rival groups, it interrupts everyone within earshot whether or not they're the intended audience. A silent, visual signal that only registers with whoever is already close enough to be looking at your face solves a problem the scream creates. It lets you say something is wrong without saying it to everything in range. There's a second piece to this that researchers studying infant attachment have leaned on heavily, and it involves something almost embarrassingly practical: darkness. Human infants, like most primate infants, are frequently held or nearby a caregiver who isn't making direct eye contact at every moment, especially at night. A scream reaches a sleeping or distracted parent regardless of visibility. But as an infant grows and caregivers start relying on facial cues to gauge how urgent a cry actually is this hunger? Is this pain? Is this real distress or fading protest? A visible marker that only shows up when things are genuinely serious becomes useful information. Some researchers have proposed that emotional tears may function partly as an honesty signal even at the infant stage, separating a routine fuss from a cry that a caregiver needs to take seriously right now. Whether that holds fully for newborns is still debated, but the underlying logic, a costly, hard-to-fake visual cue reserved for real distress, lines up with everything else the evidence points toward. If any of this is landing for you, subscribe and turn on notifications. It genuinely helps us keep making videos like this one. Here's the part that tends to surprise people most, because it cuts against the instinct that crying is purely a grief or pain response. Humans cry from joy, from relief, from watching a stranger reunite with a lost dog in a video, with no personal stakes attached whatsoever. No other proposed function, not the blur, not the honesty signal, not the silent alert to someone standing close, fully accounts for that on its own. Researchers studying what's sometimes called tears of overwhelm have found that positive emotional crying tends to cluster around moments of intense connection or a sudden release of built-up tension, rather than happiness in some general sense. You don't cry when things are simply fine. You cry when something that mattered resolves, one way or the other. That pattern suggests tears aren't really tracking sadness or happiness at all. They're tracking intensity that's crossed a threshold. In either direction, in a moment where connection to another person or a shared experience is somehow involved. That reframes the entire question. The instinct is to ask why crying evolved to express sadness, and treat the joy crying and the relief crying as strange exceptions bolted onto the main system. Flip it around, and the exceptions stop being exceptions. Tears aren't a sadness signal that occasionally misfires into joy. They're an overflow signal, built for any moment where what's happening inside a person exceeds what words and posture and a raised voice can carry on their own. And grief just happens to be the most common thing that pushes people past that threshold. It also reframes why the mother in that opening scene has something the chimpanzee doesn't, and it isn't a deeper capacity for loss. The chimp's grief is, by every measurable behavioral standard researchers have documented, real and profound. What she's missing isn't the feeling. It's a channel built specifically to let that feeling become visible to another creature at close range, silently, in a form too costly to easily fake. She has every tool languageless grief requires, except the one that turns private devastation into something another individual can witness without a sound. That's the actual answer sitting underneath the strange biology. The mismatched infant timeline, the drainage duct that overflows because the face went flat, the protein-heavy fluid the body bothers to manufacture on purpose. Every other species capable of loss carries that loss alone, sealed inside a body with no mechanism for making it visible except noise. Humans built a second option somewhere along the way, one that doesn't compete with the scream but sits quietly beside it. A signal that only works because whoever it's meant for is already close enough to see it. Thanks for watching. More videos are on your screen right now, and if you haven't already, go ahead and subscribe. See you in the next one.